Okay, this is trying to answer questions 3 and 4. First one, the transition state shown below corresponds to an elementary reaction. Which of the following are possible rate laws for the elementary reaction? Choose all that apply. Now, rates, all right, rates is equal to some constant times the concentration of one reactant, let's call it react 1, um, times the concentration of react 2. Okay, now it's got to be in what's called the RDS, which is the rate determining step, which is the slow part of the reaction. Okay, now it hasn't given any information about that, so all we've got to go on really is what are the reactants, and we'll put them in. Okay, now looking at this looks like there. It looks to me like ethanoic acid, which is CH3, COOH. And this guy at the bottom, what do they call these? I think these are called, this is an epoxide, okay, which is a cyclic ester. Okay, and this guy has this kind of shape, CH2, CH2. And then there's a bridging, what we call a bridging oxygen, like that. Okay, that looks like that. Okay, so what's happened here is as it's got close now, as this guy here is this epoxide, I don't know what this one's called, ethene epoxide, I don't know what it's called. But as it gets close, these electrons go here, yeah, and the lone pair on here go here, and so you'll get something like what the picture looks like. O, H. That's what the original picture looked like, wasn't it? Oh, that's an O. That's not right at all, is it? Messed that up big time. Okay, let's get rid of that. This becomes CH3, C, and this is an O. That was my original ethanoic acid. But now there's a bond there to the oxygen. There's a bond there to the hydrogen, and everything else is like that. It looks like that anyway to me. So this looks like that. So what is the reaction rate then? Well, the rate is equal to some constant, the rate constant, times the concentration of the ethanoic acid, which is CH3CO2H, times the concentration of this epoxide, which is C2. I'm looking at your answers here. Oh gosh, sorry, messing this up. C2H4O, this guy. So that's one possible rate. So this one is good to go. All right, what about number 2? Let's call these A, B, C, D, and D. Well, obviously E is rubbish now because I found one, haven't I? It's A. All right, let's have a look at B. B is very similar, but it's got the acid. Let me do this now. It's giving the oxygen to the acid. Okay, so let's redraw this one. It's a different color. Green. So this one is all of this and that now. Okay, so that's possible as well. So this is CH3CO3 now and C2H4 this. So this is possible as well. It could be in this, we could split them up like this. So the rate would be equal to K into CH3CO3H and C2H4. So this one's possible as well. All right. Carbon dioxide and OH minus. Well, where the hell is that? That's nowhere here, is it? So that's wrong. The next one looks good, but they're missing out an O. They're missing out an O. And they're missing out an H from this, which isn't in this intermediate. So these species have to be in the intermediate, eh? And these ones obviously aren't, and these ones aren't either because they're missing atoms. So I'm going to go for these two. I know it's the answer because I obviously looked at your answer scheme, but that's the explanation around that. Okay, let me stop the video because I need to get some pictures for the next one. Okay, so which atomic orbital can participate in a pi bond with a px orbital? The x-axis is the bonding axis. So, sorry, the z-axis is the bonding axis. So, oh, I've done it wrong, haven't I already? So let's get rid of these. Okay? I've messed up my scales here. All right. Now, so this is the bonding axis Z, and this is Y, and this is now Z, and this is Y, and this is Z, and this is Y. So let's draw a PX orbital to start with. So this is the X and the PX. Let me do a different color. This green one's a nice color. This is a PX. Okay, there's a PX. Okay, now will it overlap with a DXZ? Okay, so what does a DXZ look like? This is the DXZ, it's a d orbital, and it's going to have a lobe there and a lobe there. Okay, is that gonna be able to overlap? Well, it looks like it could, doesn't it? Because let me try a different color. This orange. This can overlap sideways with this lobe, and this can overlap sideways with that lobe. Okay, so yeah, because a pi bond, by the way, is sideways overlap, isn't it? I think the proper definition is non-rotational if you look along the bond axis, but don't worry about that. It's side on overlap. All right, at A level it is anyway. So look, yeah, they can overlap with each other, can't they? So I'm going to say, yeah, we're good for this one. I missed out the S because an S can't form pi bonds. Okay, it can't overlap with both lobes, so we can't do that. All right, so that's a good answer. Obviously, none of these is wrong now, isn't it? Can it form a pi bond with a px? Well, yeah, it can. Let's try and create a px. Okay, get rid of this one because I've just done that. What's a px look like? Well, a px and a px. Obviously, I'm changing this d orbital into a px, and yeah, of course they can overlap, can't they? They can definitely overlap. So that one's good as well. That can side on overlap. All right, and the bond axis is this one, is Z. Okay, so that's good. How about DXY? Now let me get my rubber here. I want to get rid of this thing. I think so anyway. There you go. And let me say, sorry I'm faffing around here. These questions, they're good questions, by the way. The next one I'm going to have to do some research on the tin one. Oh, I haven't got a clue where I'm going to start with that, but it's good fun doing it. All right, let's grab this and move it over. Okay, that didn't work, did it? All right, so this one is the y-axis and the z-axis. All right, now what is it? dxy. So there's another one there. This is the x, and the y, it goes in this direction and out there. Okay, now because of the orientation of this, okay, it can't overlap with this and this because these other ones will kind of they can't, there's nothing for them to overlap with there. Okay, so it won't overlap just like that. Okay, the other one would because of the orientation of the DXZ, but this one can't. Okay, it's an orientation thing. Okay, so this one doesn't. Now I know I haven't explained that very well, but unfortunately you're going to have to look that one up because I haven't got the nice pictures here. But it's the orientation. The DXZ can overlap with it because the Z goes along this way, doesn't it? And it can overlap nicely, okay? But the other one can't. It's just an orientation thing, okay? So the answer to that one is this one and this one. I hope that makes sense. I don't think I've been very clear on that, but maybe you've got the idea now. It's an orientation thing. It won't overlap with it. Okay, let me have a look at number 5.